Welcome back. So we will be discussing a very important topic that should be the VDS, Virtual Distributed Switch. So basically it's like a centralized switch. Instead of having many switches in your ESXi host, you can create one centralized switch on the vCenter server and you can manage your traffic. Now, the main thing is that you have to understand how the traffic works over here. So let's take an example of the cluster one, which I have three hosts in it. So ESXi 1, ESXi 2, and ESXi 3. And if you remember, I do have three switches, switch 1, switch 2, and ST switch. So now my ESXi 1, two links are connected to switch 1, two links are connected to switch 2, and two links are connected to storage switch. Again with the ESXi 2, two links are connected to switch 1, two links are connected to switch 2, and two links are connected to storage. Again with the ESXi 3, two links are connected to switch 1, two links are connected to switch 2, and two links are connected to switch 3. So those are the uplinks how we have configured on the ESXi on the physical bare metal. But from the inside perspective, logically, if you see that we are connecting all the networks to the VM network. Now, VM network is a part of the one whole switch, and currently this whole switch is running on the management switch. That is our bridge adapter. That's it. And the remaining all the six adapters we are not even using right now. So in fact, if I go back to my vCenter server and if I say if I go to one of the hosts and if I click on configure, and if I say virtual switches, and you see that I do have only one NIC assigned to that default switch, and there is one default port group created and a default management created. That's it. So all the remaining seven uplinks, we are still not using it. So now what we can do is that now we can create a vCenter distributed switch now, which will be acting centrally. And we can assign these all the six uplinks of each of the ESXi hosts to this particular distributed switch. And once it is been assigned all the six links appropriately, so again I will do the same thing. So how I mapped on the ESXi on the distributed switch also I will map the same thing. So I will be creating a virtual distributed switch and I will say that I want to assign 8 uplinks, but I will be using only 6 for now. So uplink 0 will be my ESXi uplink number 2 because 0, 1, 2, 3, 4, 5, 6, 7. So these two belongs to the bridge. These two belong to switch 1. These two belongs to switch 2. And again, these two belongs to the bridge. So uplink 0 will be 2 and 3. Uplink 1 will be 3 and uplink 2 will be 4. Uplink 3 will be 5. Uplink 4 will be 6. Uplink 5 will be 7. So this is how the numbers I will assign it on the. So I'm doing the same thing. I'm only mapping the uplinks. So currently I'm just saying that the uplink number 0 of the VDS switch will be mapped to the uplink number 2, which is connected to switch 1, and uplink 1 will be mapped to the uplink link of the ESXi network adapter, that is number 3, which is also connected to switch 1. So in this way, First two will be my switch 1 connected adapters. Second two will be my switch 2 connected adapters. Third one will be my bridge adapters. So once we create that one, so by default, we will create one port group and we will say that switch 1 VDS port group. So by default, there should be one uplink assigned to it. And we say that it is uplink 0. And we will create one more port group that will be switch to VDS. And again, we will assign a separate uplinks. So 0 and 1 will be assigned to the first port group, and the second and third will be assigned to the second switch to port group, and the STVDS port group will be assigned as a uplink of 4 and 5. So in this way, I am keeping the topology exactly the same, how the uplinks are connected over there. So you have a capability that you can just connect all the uplinks to the all the switches and all the port groups. But it doesn't make any sense because if all the uplinks are connected and all the port groups have access to the uplink, the traffic might be mixing over there. So we don't want that one. So we separately map the port, what do we say, Ethernet adapters to the switches on our workstation, and on our virtual distributed switch also we are going to do the same thing. So now what this will give you an idea that I do have now switch 1, switch 2 and the ST switch. Now I'm deploying a virtual distributed switch. So whenever I say that uplink VDS switch 1, VDS switch 2 and ST, sorry, VDS ST. So whenever I assign any virtual machine, irrespective of host, it can be any host 1, 2 or 3. All right. So I'm just assigning VM1 for the switch 1 and I'm assigning VM2, so the switch 2, and VM3 to the switch 3. So understanding here is that if you remember, these two switches are the host only switches. So if I connect to this one, that means whatever the VMs connected on this particular port group will only be able to communicate simply. So even if I mix the all the port links together and all the port groups have the access to the port link, still one port group cannot communicate with the another port group. So vCenters, virtual distributed switch will stop the communication between any two port groups. So my intention over here is just to map properly so that when I connect, I know that it is connected to this switch, and when I connect to this port group I know that it is connected to this switch, and when I connect to this port group I know that it is connected to the storage switch. So in this way you will have an idea exactly when you assign a virtual machine to the port group, you know exactly outside where the traffic is going to, which device it is going to, and if you are planning to do the routing and make the virtual machine to communicate with the internet, you know exactly which switch has the access to internet and how they are connected. So thinking these are the virtual switches which are on your organization or in your data center, no matter where it is, but physically connected, so logically inside the vCenter server. But if you remember, my vCenter server is only on the management switch. So vCenter server actually doing nothing. It is just taking the information from the ESXi host. So it is taking the information. It has the port groups or network adapters from 0 to 7. So we are only using from 2 to 7. So we are only vCenter server is only taking the information from 2 to 7. And we are correctly mapping that information so that we know exactly where the traffic is going. So if you just say to all the port groups that you connect to the all the ports groups should have access to all the uplinks that is 0 to 5. So I think that doesn't make any sense because in that way what happens is like all the port groups have access to this one and this one. You don't know exactly where the traffic is going on now. So you are left with like, okay, I am connecting to the port group, but still it is not communicating, and you don't know exactly because it can go with the any of the adapters, and you don't have any proper mapping means you cannot track that traffic. So that's the reason it's very important you properly map the adapters to the particular switches so that you exactly know that when you assign a port group, you know the traffic is going to that particular switch and it will be easy to do the troubleshooting. All right, so let me go ahead and create the distributed switch. So I will go back to my data center over here, right click and click on distributed switch, click on new distributed switch, and I will say that DC1 VDS, click on next. So here it is asking you for the version. So if you have any ESXi host which are version 7 or 6, you have to select appropriately, otherwise the virtual VDS, virtual distributed switch will be not be supported on that particular host. So be careful with that one. So I will select the ESXi 8 because my all the ESXi versions are 8. Click on next. So we want the uplinks. Currently 6 is enough, but still I will give it a 8. Network control, IO control, keep it enabled. And I want to create a default port group. I will say VDS switch 1 for now. And the remaining port groups I will create it later on. Click on next and click on finish. So it should now create the virtual distributed switch now. So now if I click on configure or summary, monitor, so I think over here it will show up the, okay, it's here topology now. Now you see that I have a switch, but there are no host connected right now. So what I will do now is that I will go ahead and connect the host. So I will right click on that one. I will say add and manage host and I will select add host, click on next and I will select all three of them. Click on next. Now this is where you will map it now. So in use by switch, assign uplink to number 1. So it is not using from 0. So and you see that now I will say on the ESXi host 0127, it is asking me how you want to assign the uplinks now. So I will select from number 2 because 0 and 1 are the management bridge one and I don't want to disturb the management. And also keep in mind that whenever you are doing the lab, make sure that you do not disturb the management adapters because sometimes you will lose access to the vCenter server and you're not able to retrieve it. What happens is that we are now migrating. So migrating means what the vCenter will do is that it will take all of these adapters and it will transfer to the VDS switch. So they are still physically present over there, but software, according to the software, that will be present on the VDS and there is nothing on the ESXi host. So that's how it behaves. So be careful with that one. So whenever you're doing the practice, so do not migrate the management networks to the uplinks. Just keep the management network as it is. Don't do anything. Just the data traffic where we are going to send the data traffic, that's where you will start assigning the uplinks. So now over here, I will say assign the uplink to 1, assign the uplink to 2, assign the uplink 3, 4, 5, and 6. So I'm using from 2 to 7 as per my what requirement. So that's it and cancel. Okay, let me see. Assigned 0 adapters have been assigned. So these are the adapters which are on the host. I will go ahead. That's what I was doing. That is correct. 3, 4, 5, and 6. So you see that manage physical adapters. So click on next. Now it is asking you for the VM management one. So I'm not doing anything. So if you click on that one, you see that three of them have the management also. So you can assign it to port group if you like, which I don't want to do it right now. So do nothing. Do not migrate the management one while doing the practice or lab. But if you're doing the, what do we say, in the production, definitely you will be migrating because over there you do have a vCenter cluster, so you don't have to worry about it. So click on next. Configure network per network adapter per virtual machine. So I don't, if you want to migrate your virtual machines, you can click on over here and you can migrate your virtual machines. So currently I'm not migrating anything. I will do it manually later on. So click on next and click on finish. And now after a while, I should see there are uplinks now connected, and that's all. So you see that all the ESXi machines have been connected, the uplinks have been connected. So it's fantastic. So now my uplinks are ready now. But still, if I turn on this machine, okay, what's happening with this one? It's not turning on the machine. Check the second one. Okay, I just shut it down the vCenter server. I think that has caused a problem. What I will do is that I will delete and just redeploy the virtual machine quickly. Okay, delete everything. Alright, so let me deploy that OVF file quickly. Deploy on DC1. That should be under the host of 201. A fatal error has unable to continue. Okay, looks like there is a problem with my machines. So let me go to the ESXi machines. Should be power off, and power off. I will increase the RAM to 8 GB. Hopefully that should fix the problem. Okay, let the virtual machine start. Alright, so I have recreated my whole topology. So due to some issues in the version 8.0, I have to downgrade to 7.0. So I have reinstalled the whole infrastructure using the version 7.0. But the configuration and the steps will always be the same. About the VDS switch, as we discussed, I will be creating a VDS switch. In that VDS switch, I will be creating the port group switch 1, VDS, switch 2, VDS, and ST VDS, and that will be connected to the respective uplinks. All right, so that was my idea to create that one. So I will go ahead and create that one. So I'm in my vCenter works, what do you say, vCenter server. So if I come back here and you can see that I'm back to 7.0.1 version. Right, that's all good. So let's go to the data sensor, right click on that one, click on new distributed switch, or you can, I think over here also you can create, no, only in the data center you can create. So right click, new distributed switch, click on new distributed switch and give a name. So I will say this one as DC1 VDS switch. Click on next. And again, I am selecting the version for the distributed switch. That means it will be the lowest will be the 7.0. Or if you have any ESXi machine which is lower that one, that is a 6.5 version, then you have to select this version as a minimum version. So currently everything is 7.0, so I don't worry about it. So click on next. So number of uplinks as usual, I will give it a name, number 8, and I will create a default that will be switch 1 VDS port group, and click on next and click on finish. So my distributed switch should be created over here now. You see that? So I will click on right click and I will see that I will add and manage host. So I will add the host, click on next, click on add host, select all of 3, click on OK, click on next. Now VM 0 and 1 I will leave it for the management, so I will select from number 2. So VM NIC 2, assign it to VM NIC 1, that is my uplink 1. I will select this one, apply this uplink assignment to rest of the host. So I'm mapping the VM link to number 2 to number 1 because that's what my port group is switch 1, so accordingly. And VM3 I will assign it to 2, and VM4 I will assign it to number 3, and VNIC 5 I will assign it to NIC 4, and 6 I will assign it to 5, and 7 I will assign it to 6. Alright, so that's how the things are mapped at the back end. So accordingly I have mapped the uplinks, and combining the all the uplinks we will look that scenario later on, but for now I'm just keeping it straightforward so that we have a proper understanding how the traffic is moving. So I'll click on next. Now I'm not upgrading this or migrating the management. So if you are in a production, that should be good, but in the lab I do not recommend you to migrate the management VM kernel. Click on next. I'm not migrating any virtual machine right now, so I will click on next. And you see that I have added 3 hosts and there are 18 physical adapters, 6 from each of them. Click on finish, that's it. So that should be all good. So if I click on this one, now I should see the topology. So that should be configure topology, and you see that my uplinks are created over here. So now what I will do is that I will go to my port group, click on configure, and otherwise I'll go back to my distributed switch, click on configure, click on topology. I will click on edit settings of this particular port group, and I will bind it to or teaming. I will select the number 3. All right, so this is another topic over here. So first what I will do is that I will assign the uplink properly to the port groups. So first let me create all the port groups. I will right click on that one and I will say distributed port group, new distributed port group, that should be switch 2 VDS. Click on next. Port binding is static, just keep it at once. Nothing, no changes, nothing. Number of ports by default it is 8, we keep it at 8. So click on next and finish. And I will create one more, that should be ST VDS. Right, so now I want to map this one. You see that when I click on this one, it is all connected to all the three of them, but I don't want that to happen. So I will select edit settings. Let's go to the advanced, nothing VLAN. Nope. Let me check on this one. Let me go to team and viewing. So now teaming and failover means what you can do is that you can assign uplinks to the particular port groups. So currently when I click on any of the uplinks, it will say that every uplinks is connected to every port group, which my current requirement is that I don't want that one. So what I want is that I want the switch one port group to be connected to uplink number one and number two, where I will say that the number one will be the active one and number two will be the standby one. And similarly for the switch to port group, I will say that I want to give the uplink that should be number three and number four. Number three will be the active and number four should be the standby. And similarly for the ST port group, I will assign the uplinks that is number 5 and 6. 5 will be the active and number 6 will be the standby. So in this way, what we are having is that we are having a high availability over here. We are teaming them. We are doing a NIC teaming. So we are just combining two of them and making them like a higher active standby configuration so that one goes down, then the other port is up and running, so through which it will be connected. All right, so let me go ahead and configure that one. So over here, you see that 1 and 2 should be selected. So what I have to do is that I have to select number 8 and click on this one. I don't want to use that one. Number 7, I don't want to use. Number 6, I don't want to use. And number 5, I don't want to use. As well as number 3. I and number 2, I only want to be number 2 be as in standby, but the active uplink should be number 1. And you see that it is going with the route based on originated virtual port, so it is looking as the routes. So you can again change that one accordingly, but keep it as a default until unless you have a certain requirement. Link status only, or you want to get the probing, so by default keep it as network detection, keep it as a link status, so it will detect the link. Next, traffic shaping, I'm not doing anything. Monitoring, I'm not doing anything. Miscellaneous, don't worry about it. Security, we don't worry, so click on OK. So now if I click on uplink 1, that should be switch 1. Okay, again it is showing me that it is connected to 1, 2 and 3, which should not be the correct one. If I go ahead editing, need teaming. Okay, I think I have assigned the wrong one to the STD. Yep, that's the one. So I will just keep it as unused. For the this one, I will remove it. Click on OK for now. You see that no uplinks are assigned for that one. So I will fix it one by one. I will go back here to switch 1 and I will say that I want to use only 1 and 2 first. So 1 should be active, 2 should be standby. That should be good. And now if I click on this one, I will also fix this one also now. That should be 3 and 4. Okay, we can select multiple. That's good. All right, that's all good. So 3 should be active, 4 should be standby. So that is all done. So let me fix this one also. That should be 7 and 8. So 1 to 5 I will, okay, 1 to 4 I will remove it. Unused. So I will say that the uplink 5 and 6. So 5 should be active, 6 should be standby and click on OK. Now if I say that if I click on uplink 1, you see that uplink 1 is only connected to this one. Uplink 2 is also connected as a standby for this one. When I click on uplink 3, it is connected to switch 2. And if I click on uplink 5, that is connected to switch 5. That's what my setting is. Now let's go ahead and connect our virtual machine. So what I am going to do is that I am going to connect my MKT number 1 to this one, and I'm going to connect MKT2 to this one, this port group. And after that, I will try to ping. So this one should be 10.1.1 and this one should be 10.1.1.2, and I will try to ping it. Let's see whether it pings or not. So I will go back to the virtual machines. I will select this one and I will click on actions, edit settings. Now I will just select this one, click on browse and go to the switch one VDS. So currently I'm testing with only one adapter, so I'm just changing that one adapter. That's all good. Now I'm going to VD MKT2, edit that one, and I will click on browse and select VDS2, click on OK and OK. And in the summary, I should see, you see that the first port is VDS2, and here it should show the first port as VDS1. So let's take the access for that one. For MKTR, and I will say IP address address equal to 10.1.1/24 for interface Ethernet 1. And I will take the MKTR2 machine also. So here also I will say that IP address address 10.1.1.2/24 interface will be Ethernet 1, and I will say ping 10.1.1.1. Now you see that it is not pinging. Now the reason for that one is that by default, one port is not able to communicate with the another port. And also this one port is connected to switch 1. In my diagram, this one port is connected to switch 2. That will also doesn't allow to communicate with that one. So what I will do, I will create one more switch port for testing. That should be switch 3, and I will connect that switch 3 to the switch 1 port and see when I am then I will transfer the 2 to the switch 3, and I will see, because these two port groups are connected to the same switch, and after that I will try to ping each other. So let's go ahead and create that one now. So I will go to the networking, right click and new distributed port. That should be switch 3 VDS. Click on next, and I want to don't do anything, click on next and finish. And now if I go to configure topology, I should see VDS3. So I will click on edit, and here I will go to tick naming and I will select 128 as unused. Only I will keep the uplink 1 as active. So in that way, what happens is, like when I select this one, so it is going to switch 1 as well as switch 3. So now I will go back to MKTR2, click on edit and settings. I will click on browse and I will select switch 3. Right, so let's go back to the topology again. And now you see that switch 1 is connected to 1 and 3, but my machines are connected to two different ports. So number 1 machine is connected to switch 1 and number 2 is connected to switch 3. So by default behavior should be like, even though they are connected to the same uplink but different port groups, the traffic should not be allowed. Let's see what's going to happen now. So I will go to the MKTR2 one more time and I will say ping 10.1.1.1, and you see that I'm able to ping. Now usually the default behavior should be that it should not ping, but the reason for pinging over here is that, so what is happening here, why it is pinging when it should not be. So number 1 is connected here, number 2 is connected. So whenever the number 1 is sending the traffic over here, it is going to uplink 1, that's correct. But according to the distributed default policy, it should not be going here. So that's why the traffic is going outside to my switch 1 adapter onto the workstation, and from there again it in returning the traffic. So in that way it is violating the policy, and that's why it is like not violating, bypassing the policy, and it is able to communicate. But by default, one port group will not be able to communicate with the other port group. All right. So I will go back and I will change that settings to the switch 2, and I will delete the port group, that is this one. So right click and delete. All right. Now everything is being set up. We have created that port group and everything. Now let's discuss about the different scenarios where you can configure different settings. So now currently at present, how the things are connected are pretty much straightforward. So the switch 1 port group is connected to switch 1, which is a different switch. This one is connected to switch 1, that switch 2, that is different switch, and this one is connected to ST switch, which is a different switch. Now, in an environment in a production, usually when you have a switch 1, switch 2, and ST switch, all of them will be connected to each other using the port channel or maybe a link aggregation, LACP. And through that one, doesn't matter if you're connecting to the hosts on whatever the ports they are. So this might be the ESXi1, ESXi2, and ESXi3. So again, we do have an ability to create a port channeling using this ESXi host. So these are the physical machines. When connected to the switches, you do have ability to configure the port channel using the LSCP, and on the switch, the port channel should be coming up. So in this way, what happens is like no matter the ESXi 1, 2, 3 are connected to these three switches, now the traffic is like it can go anywhere, from anywhere to any switch. So that is now the configuration because that is been connected as a switch 1. For example, now I do have a switch 1 port group connected, which is connected to only switch 1. Now that port group can go and communicate with switch 2 because it has now a link over here. So in this way, now what happens is like you don't have to worry about the back end of the environment. You just have to look in a logical way now. So in a logical way, now your only requirement is that, okay, how you want to redirect your traffic or shape your traffic, how you want the traffic to be connected, and how those virtual machines should be communicating with each other. So what I will do, I will go back to my distributed switch now, and I will say configure topology. And if I click on uplink, you see that it is going currently to that one. So what I will say that I will say 1, 3, and 5 should be active for all of them. 2, 4, and 6 should be the standby for all of them. So I'll go to the edit settings, click on team, and I said 1, 3, and 5. So 1, 3, and 5 should be active for all of them, and 4, 6. Okay, I do have total 6 links. So 1, 3, and 5. That should be 2, 4, and 6. So 2, 4, 6 should be the standby. 1, 3, 5 should be the active. So I will do the same thing for this one now. I'll come back here. So now the uplink 1, 3, and 5. 1, 3, and 5. 2, 4, and 6 should be the standby. And I will do the same thing for here. Now 1, 3, and 5. 2, 4, and 6. And now if I click on NIC 1 now, all the three switches have access to that one. If I click NIC 3 and NIC 5. Now, in this way, what happens is like now, since virtual machine my 1 is connected to switch 1, virtual machine 2 is now connected to switch 2. So if I come back here and if I say ping 10.10.10.2, it should now ping. All right, so it is going because my switches are segregated at the back end, if you remember. So the traffic is being shaped, there is no connectivity over here, so that's why my traffic is not going. But if the traffic is being connected, then definitely it would have been access to the internet. So what I can do is that at the back end to make changes, so I can just change the switch one uplinks to the bridge ones. So in that way, what happens is like at the back end, they are only connected to one single switch, and whenever the traffic goes to any port group, switch one or switch two port group, at the back end, it is only one switch, so they should be able to communicate with each other. But I have keeping this separately for switch one, two, and storage networking. So that's why my traffic is not going from one switch to another switch because there is no connectivity for that one. Now, if I go back and if I change that switch 2 to, I will go to the action, I will go to the edit, and I will change this one to this same port group, which is connected to the same group. Now I should be having communication because at the back end, I don't have any switching done. So that's why my traffic is not able to communicate. So if I plug into the same switch, it should be able to ping. That's strange. Let me go back and check that is connected to switch 1 VDS and this is connected to switch 1 VDS. So that is the first port, right? Yeah, switch 1 VDS. Come back here, let's go to the edit settings. The first one is switch 1 VDS. Yeah, they should be able to ping, so I'm not sure why they are not pinging. Yeah, self ping is working, so 10.1.1.2. Okay, let me go to the PR2 and try to ping it. That's strange. Yeah, it should be pinging because that is connected to the same switch, everything, both of them. So if I go back to my distributed switch, click on configure and topology, and if I click on VMs, right, so now you see that they are powered on, connected over here. Click on host. Right, hosts are also there, that's fine. So if I click on networking, and you see that VDS V1 two virtual machines are connected on that one. And if I click on that one, and if I see within that port group, these two virtual machines are connected. So yeah, everything seems to be fine and it should be connected, but let me try changing to different port group and see if that works because it should be working. Let me connect to the switch 2. We do a refresh also so that I can. Okay, that's okay. So add address 10.1.1.2/24 interface Ethernet 1. Already have such address. That means okay, the one is that is the problem. Okay, I think IP address at and address 10.1.1/24 interface Ethernet 1. It's already there. So if I do a self ping, it is pinging, but if I do ping 10.1.1.2, it is not pinging. Alright, so let me see what I can do from this one because it is still not pinging. So if I say ping 10.1.1.1, it is still not pinging. So let me change the policy. Let me see what is the, you see that switch to, if I go to configure in the policies, it says currently route based on originating virtual ports. So let me change that one. So let me go to teaming and failover. Let me change it to route based on IP hash. It's saying that the IP hash based load balancing does not support standby links, so that's fine because I at least have one port uplink connected to it, so that's fine. So let me try one more time now. Yep, that's fine. You see that now I am able to ping. So that was the policy issue which was causing that one. So I will go back to my networking, go back to the distributed switch, go back to the topology, and I will make sure that I don't have the standby because I will connect all the six because the IP based hashing doesn't work on standby, so there is no sense on keeping on a standby of. So I will just change it to that one. Go to traffic shaping, click on. Now at this point of time, everything is connected to everything, so we don't worry about it. So uplink 2 is connected, 3 is connected, 4, 5, 6. So no matter what, where I connect my virtual machine to the switches, everything should be now communicating until unless at the back end I do have a returning traffic configuration going done. So let me go back to my virtual machine and try to change that adapters. Let me see if I am able to do the settings or not. So right click, go to settings, and I will change all the adapters to the bridge ones. So that should be good. Changing to the 2-second one also. So now with this, what happens is like at the back end, it is connected to only one switch so that traffic can communicate with each other no matter where I connect to the port group. Okay, that's all good now. So let me go and connect the virtual machine 2 to the different port group that should be switch 1. So second virtual machine is connected to switch 1 and the first one is connected to switch 2. Let me go to that one and try to ping one more time now. It should be pinging because no matter where I connect now, it will definitely ping until unless there is a VLAN tagging or there is some kind of policy you're running or you're just filtering that kind of traffic. Again, filtering the traffic and everything comes in advance and it will require a lot of networking stuff in that one. So we are not going in that one. So I did show you like a two simple ways, like in first where all my traffic were connected to the different switches. So my distributed switch was connected, and within that one, the port groups were connected individually. That is switch 1 port group, switch 2 port group, and ST. And in the second scenario, what happened is like there was only one switch, that is the bridge switch. And to that bridge switch, there are 1, 2, 3, 4, 5, 6, 7, 8 links connected. Now my distributed switch is connected. No matter what do we say, port group you connect your virtual machine, everything is connected because I am not running any VLAN tags over here. So if you run any VLAN tags, it will going to tag that one and it will not allow the traffic. But let me try that VLAN tag also. So if I go to my port group switch 1, so I will click on edit settings and I will say that VLAN should be VLAN number 10. So I'm tagging a traffic now. If I go to switch 2, I will click on edit settings, go to the VLAN, I will say VLAN number 20. So According to the VLAN concept, so one machine is in VLAN number 10, that is MKT1, and another VLAN 20, that is MKT2. No, it should be number 2 and this should be number 1 because this is the switch 1 and this is the switch 2. So according to the VLAN concept, they are on a two different VLANs, so they should not be able to communicate. So let's check that one out. So if I go to my virtual machine 2 again, if I say ping 10.1.1.1, now I am not able to ping because now the traffic is being tagging now. What's happening now is that my distributed switch now is tagging now. The traffic is being tagged by the VLAN tag. So for the switch 1 it is tagging number 10 and for the switch 2 it is tagging number 20. So in VLAN number 10 that is MKT2 is there and VLAN number 20 MKT1 is there. So they are on two different VLANs, so that's why there is no traffic communicating over here. So this is another way you can do your testing and configure accordingly. Again, everything is about the networking. So want to be if you want to do the networking at your backend and how you want to shape your traffic, that's where your VLANs will be helpful. All right, so that's all for the distributed switch. So it was pretty straightforward, and I think everything should be easy now. If you still have any question, just shoot out to me. I hope this was informative for you, and thank you.